Let's go ahead and go right into an example of cross sections. This is one with squares. Notice it does say set up but do not integrate, so that's kind of nice. Give us a couple functions. We'll take a look at those. And R is the base of a solid whose cross sections are perpendicular to the x-axis. So that means our shapes are going to be running this way. And we are going to integrate in respect to x. That's what that means. So since we are perpendicular to the x-axis, we're going to use the formula from a to b of a of x dx. And so let's go ahead and figure out what a of x is. Well, first off, it says that we're going to be using squares. So let's go ahead and think about that. And it really helped to watch this video and kind of see what squares or rectangles would look like, because I am really bad at drawing these, to be honest. So it would be a square just popping out. Kind of hard to draw a three-dimensional square popping out of this graph. That's actually not bad. Trust me. I guess I could use this tool over here. This would probably help out quite a bit. A little better, but still not great. So you picture this square. So what we're going to do, what I would highly recommend on these cross-section problems, what I would do is I would draw your square or whatever shape you're dealing with and write it over here. Because the goal is this a of x is the area of this shape. So we got to figure out what's the area of the shape. So it's a square. So technically all our sides are congruent. That makes things kind of easy. So if I can figure out what this length is right here, what the length is of this, then that's going to be the length of our square over here. Then I'm just taking this square, this blue square, and drawing it over here. So the length of this square will be g of x minus f of x. So it's just going to be g minus f. So g minus f, because g is the top function, minus f is the bottom function. So our length is g minus f. And so that means that our width would be the same exact thing, since this is a square. So what would be the area of our square? Well, our area of our square would be and hang on, I'll put in the balance. The area of our square is going to be length times width. Let me be consistent with these colors. We're going to have length, which is g minus f, times our width, which is also g minus f. In respect to x, and notice we're going from 0 to 4. Well, what is g and what is f? Well, actually, before we do that, what would this be? This would be g of f times g minus f times g minus f, which wouldn't that just be g minus f squared? So I just changed those and made it g minus f squared. Now let's go ahead and plug in g and f. So g is going to be 3 cosine of pi x over 8 minus f is going to be 1 minus 1 over 4x. And of course we have that squared. Let me just scroll down here, kind of clean this up, make it look a little nicer. So let's just go ahead and combine like terms. So we will have 3 cosine of pi x over 8 minus 1 plus 1/4 x. So I'll just put the minus 1 at the end. And that's squared, of course. and we're integrating from 0 to 4. So remember, we're just supposed to set up. We don't need to solve this right here. This would be our answer. And that's all there is to it. So once again, like I said, try to draw the shape out, figure out what's the area of that shape. In this case, it's g minus f times g minus f. And then from there, you integrate that, and that would give you the volume generated by all those squares from here to there.